In this video, you are going to learn problems using reduction formula, right? Look at the question. If in equal to integral 0 to a x power n e power minus x dx, prove that in minus of n plus a in minus 1 plus a times n minus 1 of in minus 2 equal to 0, right? So if this is our in, we have to prove that this equation equal to 0, right? So I am considering in. So this is the given in. I am writing my in. Now we have integration. Usually we'll be using the UDV formula and finding the answer. But look at now, this is in the form of UDV, which means this is your dV, right? If you want to find your d, easily you can write dV. This is so u dV. So dV is e power minus x dx. Just put integration on both the sides. So when you integrate dV, integral dV is nothing but v. So directly you can get v, right? Right hand side also integrate. E power minus x integration is minus e power minus x. So this is your v, right? U is x power n and v is e power minus x, right? You know the formula for it. So integral u dv equal to uv minus integral v du. What is your u? U is x power n. Du is n x power n minus 1 into dx, right? So that's all. So you can directly substitute in the formula uv, right? U x power n, b is minus e power minus x. Limits 0 to a minus v is minus e power minus x. So minus of minus will become plus. That's why I have written plus here. So integral 0 to a e power minus x n into x power n. This is our du. Du is n into x power n minus 1 into dx. N into x power n minus 1 into dx, right? Now, so I am writing this. Take n as a constant term outside and writing this in order, right? That is x power n minus 1 e power minus x into dx. X power n minus 1 means this is in the form of in. In the place of n, we have n minus 1. So in the place of this integral, you can replace in minus 1, right? So left side in, substitute the upper limit now. When you substitute the upper limit for x, a power minus a power n e power minus a minus, so lower limit is 0. So 0 into anything will become 0. So lower limit value is neglected. That is minus a power n e power minus a plus n times this is in minus 1, right? So this is your equation in. Now what I am going to do is I am going to bring this term to the left side. Bring this term to the left side. What you get? In minus n in minus 1 equal to minus a power n e power minus a. Mark this as equation number 1. So now just consider this equation and substitute n equal to n minus 1. So in minus 1 equal to minus a power n minus 1 e power minus a plus n minus 1 into n minus 1 substitute panna, you will get n minus 1 minus 1 equal to n minus 2, right? So now you multiply by a into in minus 1 equal to, multiply by a on the right side also, right? So minus a power n. Already one a power n minus 1 is there. When you multiply by a, you will get a power n e power minus a, n minus 1 a into in minus 2. Mark this as equation number 2. I am going to subtract these two because I am having, so my left hand side equation is in minus n plus a in minus 1. I have n here. So if you subtract this, so you will get, that is in the left side we have in minus n in minus 1. If you subtract, what you get? Minus a in minus 1. So in minus 1 is common. So minus of n plus a you can write. That's why I am subtracting 2 from 1, right? So subtract 2 from 1, what you get? In minus n plus a in minus 1 equal to, so this is my first equation. So minus a power n e power minus a minus this term. Minus into minus will become plus. That's why we have written a power n e power minus a. Okay. Then minus n minus 1 times a into in minus 2, right? So this plus and minus term will get cancelled. Remaining term is in minus n plus a of in minus 1. Okay. So this is in the right hand side of the equation. Bring it to the left side. It will become as plus n minus 1 times a into in minus 2, right? So this is what we have. This is what we are supposed to prove. Next problem, if in equal to integral 0 to pi by 2 theta sin power n theta d theta and n greater than or equal to 1, prove that in equal to n minus 1 times sorry, n minus 1 by n in minus 2 plus 1 by n square. Hence deduce that I5 equal to 149 divided by 225, right? So actually they have given some in. So we are going to find the reduction formula for this in. And from this we are going to substitute n equal to 5. If you substitute n equal to 5, you should get the value. So this we have to prove. Okay. So this is our problem. So I am going to find the solution of this problem, right? So listen. So I am going to I am writing what is the given in. Okay. Theta sin theta power n. Okay. So now I am going to write sin power n theta as sin theta the whole power n minus 1 theta into sin power 1 theta. Okay, you can split this. Next, I am going to write sin theta the whole power n minus 1 into, this can be written as theta sin theta d theta. Okay, bring this theta to the other side. It is multiplication, so it is associative. You can change it, right? Theta sin theta d theta, right? So now you have to apply the UDV formula, right? So what is your u here? So listen, I'm going to take my u as, so just to take your u, what is your u? U is sin theta the whole power n minus 1. So sin theta the whole power n minus 1. So now just to differentiate this, find what is du, right? What is your du? Du is nothing but n minus 1 times sin n minus 2 theta. Okay, sin n minus 2 theta into differentiation of this sin theta, that is cos theta. Okay, if you don't understand, u is x power n, consider u is x power n minus 1. What is the differentiation of x power n minus 1? That is n minus 1 times x power n minus 2. But in the place of x we have another variable, another variable, that is sin x, right? So which means you have to differentiate that again. So sin x differentiation is cos x, that is cos theta d theta, right? Again we are applying the UDV formula only. So this is our u and this is our dv, right? So from dv, if you want to, so write this as your dv. So your dv equal to theta sin theta d theta, right? So if you want to find v, you have to integrate on both the sides. When you integrate on both the sides, you will get your v value, right? But look at now, in this case also we have again two functions. Okay, so for this alone we are going to apply again the UDV method and find the solution of this, right? So we are going to find what is the integral value of this, right? So here you can consider u is theta and this can be your dv, right? This can be your dv. What is your dv? Dv equal to integral of sin theta d theta, right? So du is d theta. I want to find out what is, this is our dv. In this case your dv is sin theta d theta, right? Now you apply integration on both sides. When you integrate dv, you will get v. What is sin theta integration? That is minus cos theta. Sin theta integration is minus cos theta, right? Now you apply for this alone, you just apply the integration formula. What is the formula for this? UDV equal to UV minus integral V du. U is theta and V is minus cos theta minus integral of V du. What is V? Minus cos theta. This minus is here. Minus cos theta du is d theta, right? So I can write this as minus theta cos theta. What is the integral of cos theta? So minus into minus will become plus. Integral cos theta is sin theta. So you will get V equal to minus theta cos theta plus sin theta. You should be thorough with the formulas. Otherwise you will get some changes in the sign also, right? Integral cos theta is sin theta only, right? So this is what our V. So to find that V, again inside this we are using the UDV formula, right? So this is the thing you have to remember in this problem. Okay, so now in equal to, okay, in equal to uv, just apply. So for this now we are going to apply. So we have found out this is our u and this is our v. U du also we found, right? Now we apply the formula in equal to uv minus integral du, integral v du, right? U is sin theta the whole power n minus 1. V is minus theta cos theta plus sin theta. Okay, now you apply the limits. Lower limit is 0 and upper limit is pi by 2, right? Now minus integral v du. What is your v? This is your v. du is already we found what is our du, right? So this is our du that I have written here, right? So now you apply the upper limit. What is the upper limit value? Sin pi by 2. Sin pi by 2 value is 1. Okay, 1. Okay, now here also we have to apply the upper limit. When you apply the upper limit, what you get? So cos pi by 2 value will become 0. Sin pi by 2 value become 1. So 1 into 1, so you'll get 1 here. Okay, 1. Upper limit value is 1 minus. Now you apply the lower limit. Sin 0 value is 0. So 0 into anything will become 0. So 1 minus 0 equal to 1. So that's why I have written the value 1. 1 minus. Okay, 1 minus. Now n minus 1 is a common term, constant term. You can take n minus 1 as a constant. Okay, integral 0 to pi by 2. Okay, so what is the remaining? What are the remaining terms you have? அப்படி நான் இன்டர்சேஞ்ச் பண்ணி மட்டும் எழுதியிருக்கேன். sin theta minus theta cos theta. sin theta minus theta cos theta. sin theta minus theta cos theta. Okay. Next value sin theta the whole power n minus 2 cos theta into d theta. Okay. Sin power n minus 2 theta cos theta d theta. Okay. So now 1 minus n minus 1 times integral 0 to pi by 2. Now multiply this. Already you have sin theta, here n minus 2 theta. So when you multiply, you will get n minus 1 theta. Okay. Into cos theta d theta. Next, you have to split this. We are splitting the integration. So this constant is also multiplied. So you will get, so this minus into minus will become plus. So plus n minus 1 times 0 to pi by 2. Theta cos theta, again you have cos theta, so cos square theta sin theta the whole power n minus 2, right? So 1 minus n minus 1 integral 0 to pi by 2 sin power n minus 1 theta. What is cos theta d theta, right? So cos theta again this is in the form of, you can write cos theta d theta as d of sin theta. Cos theta d theta can be written as d of sin theta plus n minus 1 times 0 to pi by 2. So we have written, since we have given only the formula in terms of sin theta, I am changing this cos square theta in terms of sin square theta. So cos square theta can be written as 1 minus sin square theta. Now again you have to split the integral, right? So n minus 1 times 0 to pi by 2 theta sin theta the whole power n minus 2 theta d theta minus of, okay, minus of this n minus 1 into, you have to multiply this. So theta sin power n theta into d theta, because n minus 2 into 2 will become sin power n theta d theta. Okay. So now for this we have to simplify the step, right? Now listen, this is in the form of x into dx. Okay, integral x power n minus 1 into dx. We know the formula of x power n minus 1 into dx. What is the formula? X power n minus 1 means x power n by n. That is the formula, right? So your x is sin theta. So sin theta power n by n. Now you apply the limit 0 to pi by 2 plus other term, right? So now you apply the lower limit, what you get? So already we have n minus 1. This n is a constant. You can take that outside. Now you apply the upper limit. Sin pi by 2 value will be 1. Sin 0 value will be 0. So 1 minus 0, that is 1 you will get, right? Plus n minus 1 into, look at this. This is in the form of in. In the place of n minus 2, we have n minus 2. So we can write n minus 2. Again, in the same case, n minus 1 into in here, right? So that's all. So 1 minus 0 is 1 only. Now you do simplification. So n minus n plus 1, right? Divided by n plus n minus 1 into in minus 2 minus of n minus 1 times in, right? Simplify the steps. What you get? 1 by n plus n minus 1 times in minus 2 minus n minus 1 times in, right? So now what you have to do, I'm going to I'm going to collect the in terms together. So bring this term to the left side. So in plus n minus 1 times in equal to 1 by n plus n minus 1 times in minus 2. Okay, n minus 1 times in minus 2. Next, so what you have? 1 plus in minus 1 in equal to 1 by n. So what in the last step what we have? So this is equal to in plus n minus 1 times in. So both in both the terms in is common, so which can be written as 1 plus n minus 1 of in equal to 1 by n plus n minus 1 times in minus 2. So which can be written as, so 1 get cancelled, so in equal to 1 by n plus n minus 1 times in minus 2. I want only in, so bring this, divide this by n. So when you divide by n, you will get 1 by n square plus n minus 1 by n in minus 2. So this is the reduction formula. So our question is not yet over. Actually, we have to find out I5. So in the place of n, substitute n equal to 5. Substitute n equal to 5, what you get? 1 by 5 square plus 4 by 5 minus 1 is 4 by 5. 5 minus 2 is 3, I3, right? So I5 equal to 1 by 25, 4 by 5, I3. So I want to find out what is I3 also. What is I3? I3 value is 1 by n square. N square is 3 square 9 plus 2 by 3. N minus 1 is 3 minus 1 is 2 by n. That is 3 into in. 3 minus 2 is 1. That is I1. Now I want to find out what is I1. What is I1? I1 is integral, ultimate integral 0 to pi by 2 theta sine power 1 theta into d theta, right? So now you have to apply UdV formula for that. Already we have done this while solving the problem, right? This is, consider this is your u and this is your dv, right? dv is sine theta d theta. So v is minus cos theta. Apply the formula theta cos theta uv minus integral v du. Now you apply the limit alone here. So theta minus cos theta. This is pi by 2 into cos pi by 2 value is 0, right? So upper limit value will be 0 minus, substitute the lower limit value. Substitute the lower limit. 0 into anything will become 0. So this value will become 0, right? Vanish. Minus into minus will become plus. What is the cos theta integration? That is sine theta. So sine theta, substitute the limits. 0 is the lower limit and pi by 2 is the upper limit. What is sine pi by 2? That is 1 minus lower limit is sine 0. So sine pi by 2 value is 1, sine 0 is 0. So 1 minus 0 equal to 1. So that is your I1. Substitute in I3. What is your I3? 1 by 9. 2 by 3 into I1. I1 is here, right? I1 value is 1. So 2 by 3 into 1 will become 2 by 3 only. Take the LCM. So 1 plus, multiply this by 3. So 6 by 9. Okay. 1 plus 6 is equal to 7 by 9. This is your I3. Substitute in I5. I5 equal to 1 by 25 plus 4 by 5 I3. I3 is 7 by 9, right? Simplify this. What you get? 4 7s are 28. 5 9s are 45, right? Now we have to simplify the step, right? Now just to take the LCM so that you will be finding the answer, right? So cross multiply the terms. 45 plus 28 into 25 divided by 1125. If you simplify, you will get the answer as 149 divided by 225. Greater than 0 and n greater than 0. Prove that integral 0 to 1 x power m 1 minus x power n into dx equal to m factorial into n factorial divided by m plus n plus 1 factorial, right? So let us take the left hand side and we will prove that this is equal to the right hand side, right? So since there are two parameters, namely m and n, I am going to use, so far we have used only one parameter, so we have written in. We have denoted the integral as in, but we have two parameters given. I am using two, that is I am using a notation imn. So this is equal to, so this is the integral I am going to take, right? So this equal to, just I am interchanging and write. So when you interchange, what you get? Integral 0 to 1, just the interchange. Okay, 1 minus x the whole power n x power m into dx. Now you have to apply the udv method. So this is our u and this is our dv, right? U is 1 minus x the whole power n and dv. What is dv? This is our dv. dv equal to x power m dx. So how will you get v? If you integrate on both sides, you will get v. So v equal to integral of x power m. X power m integration is x power m plus 1 by m plus 1. What is your du? Du value is n times 1 minus x power n minus 1. So now you have another function here. So you have to, again you have to differentiate this. So when you are differentiating minus x, you will get minus 1. So du is minus n 1 minus x power n minus 1 dx. Now you apply in the formula. What is the formula? Integral u dv equal to uv minus integral v du. So this is the formula we have. Apply in the formula uv. So u is 1 minus x the whole power n into v. What is your v? V is x power m plus 1 by m plus 1. Limit is given, so I am applying the limit minus integral 0 to 1 v. This is our v. du is minus n 1 minus x power n minus 1 into dx. Okay, I am turning the next page. I m comma n equal to 1 by, so now in the step we have 1 by m plus 1. That is a constant, so I am taking this outside. So the remaining term, upper limit and the lower limit. Plus similarly here also we had one m plus 1 into n also. So just to take those constant term outside, remaining this integral, right? So I m comma n equal to, now substitute the upper limit, what you get? 1 minus 1. When you substitute 1 minus x is equal to 1, you will get 0. So 0 into anything will become 0. So upper limit value will become 0. Substitute the lower limit value. 1 minus 0 is 1 into 0. 0 into anything will become 0. So this value will become 0. 0 into 1 by m plus, again it is 0. So I am putting 0 here, right? Now n by m plus 1 into integral 0 to 1 x power m plus 1. I am splitting as x power m into x. Again 1 minus x the whole power n minus 1 into dx, right? So now what I am going to do is I am going to multiply by 1 minus, right? So when you multiply, so listen now, so I am going to take 1 minus here, put a minus sign here. So minus, if you put minus outside, minus into minus will become plus. So I am just putting 2 minus here. Okay, I am introducing two new signs. So minus n divided by m plus 1 integral 0 to 1 minus x the whole power n minus 1. Okay, next term. So listen, so you have to multiply this. So 1 minus, just to multiply this, what you get? 1 minus x. So this is our variable 1 minus x power n minus 1. So the next term in the variable x, I am just adding and subtracting 1. Add and subtract 1. So the value will not change, right? So the x power m is remaining as it is. Okay. So minus n by m plus 1 integral 0 to 1. Now x power m 1 minus x, I am just changing. If you want, in the beginning itself you can write x power m into 1 minus x power n minus 1. In this I am writing, so just I am going to split the bracket, right? 1 minus x minus 1 into dx, right? So now you can multiply. So this is now this is a term. So you can, when you multiply, you will get two terms, right? So first this term, right? Minus n by m plus 1 0 to 1 x power n 1 minus x power n minus 1 into 1 minus x. So into 1 minus x into dx minus, now the whole term is multiplied by 1. So minus, already one minus is there. So minus and minus will become plus now, right? So minus into minus plus. So n by m plus 1 0 to 1. Then x power m 1 minus x power n minus 1 into minus 1. Okay, minus 1. Minus into minus plus. So I have put plus here, right? So minus n by m plus 1 integral 0 to 1 x power m. Okay, already 1 minus x power 1 is there. 1 minus x power n into dx plus n by m plus 1 integral 0 to 1 x power m 1 minus x power n minus 1 into dx, right? So I m comma n is equal to minus n by m plus 1 I m comma n plus n by m plus 1. Look at this, actually this is our beginning I m n, but in the place of n we have n minus 1. So just to replace that, I m n minus 1, right? So now I am going to bring this, since we have left side I m n and also in the right side also we have I m n, right? So if you bring this to the other side, it will become 1 plus n by m plus 1 into I m 1. Okay, I m n equal to n by m plus 1 I m comma n minus 1. Take the LCM, m plus 1 plus n divided by m plus 1 I m n equal to n by m plus 1 I m minus 1. You can take this term to the other side. So I m n equal to n by m plus 1. When it goes to the other side, it will be divided, which means we have to multiply this with this reciprocal. The reciprocal of this equation is m plus 1 by m plus n plus 1 I m n minus 1. Okay, so this is what we have. So I m n equal to n by So this m plus 1 get cancelled. So n by m plus n plus 1. Okay. So this is what we have. So now actually this is the formula. Now we have to get the ultimate integral. Actually in our question we have to prove that this is equal to some factorial term, which means you have to deduce the equation still. Okay. So imn equal to, so this is what we have. So look at now, if we have m and n, how we are writing? We are writing this n, then we are writing m plus n plus 1, and im from this step we are subtracting 1. Okay, so n minus 1. So now you deduce this by applying the same formula. So you have to write this as it is. So n minus 1 divided by, add this with 1. So m plus n minus 1 plus 1 into im n minus 2. Subtract 1, so you'll get n minus 2. Similarly, you have to proceed the same, right? So in the next step, what you get? N by m plus 1. N minus 1 you have. So next step you will get n minus 2 by m plus n minus 2 plus 1. That is m minus 1 into etc. into. So actually it will end with one number, right? So I m comma n. So listen, we have n minus 2. So definitely it will end with the number 0. So I am writing. There is no change in m. But only the variable n is reducing. So at last it has to go on end with 0, right? If it is 0 means what could be the next term, before term? So if it is 0 means the before term will be, so if it is n minus 2, you have to add 1 here, right? N minus 2 means if you add 1, you will get n minus 1. Then what you have to do? You have to add this number, plus 1, right? So this is what we will be doing, right? So you will get 1 and divided by, you have to add both the number with 1, right? So m plus 1 you will get, right? So m plus 2 you will get. So 2 by m plus 2 into im comma 0 you will get, right? So this is what we are having. I will repeat this step. So n by m plus n. So the first step as it is, second step as it is. It will go like this. So when it goes, it will be ending with 0, im comma 0, right? So 0 means how will you write? 0 means how will you write? So look at the previous step, right? Previous step is, if we have n minus 2, you have to add 1 here, right? If you add 1, what you get? N minus 1. That is what here, right? So how will you get the last step? So m plus n minus this term, m plus n minus 1 plus 1, right? So the same we have. So im comma 0 means what will you get here? So listen, how will you get? So you have to add 1 here. So you will get 1 divided by m plus 1 plus 1. That is m plus 2. That's why we have m plus 2 im comma 0, right? So im comma, now we have to find out the ultimate integral im comma 0. Im comma 0 means in the place of n you have to substitute 0. So in the equation substitute n is equal to 0. So integral 0 to 1. If you substitute m is equal to 0, n equal to 0, the whole anything power 0 will become 1. So that's why we have 1 here. So x power m into dx will become x power m plus 1 by m plus 1. This is integral 0 to 1. Okay. So limit 0 to 1. Substitute the limit. First you have to substitute 1. 1 by m plus 1 minus 0 by m plus 1. 0 by anything will become 0. So 1 by m plus 1, right? So we have got the integral. So now you substitute in the place of im comma 0. Substitute the value. So already we have m plus 2 we have, right? Now im 0 is 1 by m plus 1. So it will be ending with m plus 1. So now you have to get the answer. So how will you bring the answer? So look at the numerator. It is in the form of n factorial. It is in the form of n factorial. So I am writing n factorial. Okay. Look at the denominator. Denominator it is starting from m plus 1, m plus 2, etc. m plus. If it is starting from 1 to m, then you can write this as m plus n the whole factorial. So for that purpose, I am multiplying in the denominator from 1 to m. If you multiply, if you are introducing a new value, right? So the whole value should not be changed. So I am multiplying and dividing by the same value here, right? So 1 into 2 into m divided by 1 into 2 into m, which means, so this is m factorial. Look at now 1 to m plus 1, m plus 2, etc. m plus n plus 1. So this is m plus n plus 1 factorial. N factorial, m factorial by m plus n plus 1 factorial. This is the answer for this problem.